We're going to do more integration by parts in class, and in this video, I'm going to do a special example of integration by parts. This one works with integration by parts, but might not be one you would be able to figure out without seeing me do it first. This oftentimes works when we have when we have an exponential function and a trig function together because they're both very cyclic in nature. So let's see what happens here. So we're going to get started with integration by parts. I try integration by parts on this problem because e to the x and sine are not related to each other by a derivative at all. So substitution wouldn't work, and there's multiplication here, so this isn't just a simple integral. So when I pick my u, remember I'm going to use lipt. I don't have a log function here. I don't have an inverse trig. I don't have a polynomial, but I do have a trig function. Sine is trig. E to the x is exponential. So I'm going to choose sine to be my u, and then everything else to be my dv, which is the e to the x dx. V is easy, that's just the integral of e to the x, which is e to the x, and du is also easy, that's going to be cosine of x dx. And so we can put everything back together. We have e to the x sine of x dx is equal to u times v. So that'll be e to the x sine of x minus the integral of v du, so e to the x cosine x dx. Okay, so now we see that we have an e to the x cosine x. That looks an awful lot like what we started with, so we probably need another integration by parts on this. Again, our first thing that we find on lipt is a trig function, so we'll make cosine x my u, my du then is negative sine of x dx. My dv is e to the x dx, and my v will just be e to the x. So let's substitute everything in here. So I'm just going to rewrite all of it. You might not know, you might not want to rewrite all of it, but it will actually be useful. Okay, so now I'm going to write in red all of this stuff. So I'm subtracting u times v. So e to the x cosine x. Integration by parts would normally have a minus at this point, but we have an extra negative that's going to get distributed. So this will be plus the integral of these two guys multiplied together. So I have e to the x sine x dx. And now there's an extra negative from here. So I'm going to go back and make this thing negative. Okay, so now we've gotten down to e to the x sine x, that integral again. Oh no. So we were gotten stuck in a rut. That was the thing we were originally trying to find. So you might say, well, Dr. Krieger, integration by parts doesn't work here. But let me show you what we found. So we have the same integral on both sides of the equation. So what I'm going to do is I'm just going to add, because it's already being subtracted, I'm going to add this integral over to the other side. So I have two of the same things being added together. So I'm going to have 2 times that integral. I'm going to have 2 times the integral of e to the x sine of x dx is equal to this stuff. E to the x sine of x minus e to the x cosine of x. That behaved really nicely. This is going to happen when we have a trig function times an exponential function, usually because of the fact that like the trig functions are going to cycle. The sine and cosine will cycle from sine to cosine back to sine. And so that's why we kind of got back to where we started. That exponential piece really essentially stays the same. So now we need to divide by the 2. So I'm going to get integral e to the x sine of x dx, all of this divided by 2, e to the x sine of x minus e to the x cosine of x. And we can't forget our plus c here. The plus c can either go in the numerator, it can go on the outside. And that's because we were finding an indefinite integral. So we don't see these problems too often, but it's good to have seen at least one of them, and we'll do at least one more in class.